Hey there, Dr. Clark here, and in this next set of videos, we're going to be talking about how to summarize and visualize data. So this will help you with putting together a summary for your pilot data and for all of your data from your main experiments as well. So just to give you kind of an outline of the topics we're going to cover in this next series of videos, first we're just going to get started talking about describing data. Then we'll talk about how to describe the shape of data distributions. Then we're going to talk about how to describe spread, so all about quantiles, box plots, and standard deviation. Then we're going to dive into choosing the best graph for your data. We'll talk a little bit about populations versus samples, and then we're going to really roll up our sleeves and dive into making plots in R. And by the end of this series, you're going to have developed some pretty sophisticated skills working with R. Okay, so to start out with for this, I want to just briefly recap from Dr. Burke's video about types of response variables. So, and remember, those contrast with explanatory variables. So here's just a quick list of the different types of response variables that Dr. Burke outlined. So we've got numeric or so we've got numeric or categorical variables. Within numeric, we've got continuous and discrete, and within categorical, we've got ordinal or nominal variables. And for the first part of this series, we're primarily going to be focusing on numeric continuous variables. And some of these other categories of variables are going to come back into play later on in this lecture series. Okay, so to start out with, we're going to work again with the anorexia data that Dr. Burke showed you previously, and I'm going to show you how to access those data in R. And that's part of why I have kind of a funky screen layout right now, because I'm going to show these slides in miniature up in the corner, and so that we can see the slides and we can also see RStudio at the same time. So over here now in RStudio, the anorexia data come bundled in a package in R called the mass package. When we want to use, so when you install R, you don't install the entirety of those thousands and thousands of packages. You just install a limited number. And so if you discover that you need another package, you have to go back and install that individual package to be able to access the functions that are in it. So when we're doing this, we only have to install a package once, and then that package will be installed on your local computer, and then you just need to call it up after you've installed it for the first time. So I'm going to type this command into the lower left console window. So install.packages. And the package that we want is one that's called mass, all in caps, M-A-S-S. Okay. So now I've got a cursor flashing, and in my case, I've already set what's called a crayon mirror. If you get a prompt that says to select a crayon mirror, look for a location in the US that's somewhere nearby. So that tells your computer to just check that nearby location to download this file. In my case, the crayon mirror is already set, so it just went straight to installing that package. Okay, and then if I want to actually use something in that package, it doesn't automatically load into RStudio. So the first thing I need to do to work with it is to load that package. So I'm going to write a comment for myself that I'm going to start out loading the mass package in a new script file, and then I'm going to use a function called the library function to load that package. And I'll send this down to the command line, and in my case I'm getting a small warning. You probably won't see that warning, so you should be fine. Okay, so that's accessing the anorexia data. So here's our library function, and once that is loaded, if you type the name of that object, then you can see its contents. So the anorexia dataset comes with the mass package, so let's just type anorexia, run that line, and that is spitting out the information, the data that are in the anorexia data frame. Okay. So now, just a bit of a tour of what we've got in this data matrix. So you can see we have row numbers, so each row is numbered. Then we've got a column called treat that indicates the type of treatment that those individuals received. This pre-WT is the individual's weight before the treatment, and then post-WT is the individual's weight after treatment. So in this case, each row is a particular patient. So now if we're just looking at this collection of numbers, you can kind of go, okay, that's a bunch of numbers. What does that actually mean? It's really hard to make heads or tails of just a list of numbers. So we need to come up with a way to summarize what's going on, and the way that we'll do that is using summary statistics. So if I wanted to just look, for example, at body mass before treatment, I could use the indexing symbol $. Just look at that. So again, just a bunch of numbers. When we're working with summary statistics, there are two main characteristics that are useful information to summarize the data that we've got. So I've got an example here where everything is plotted together, and so here is the initial weight. Each of these points is a different individual. And here's another example of some other data where I've got different blood pressures on the x-axis here. And so these red arrows are pointing to the center, and then the gray arrows in both cases are an indicator of the spread. So what's the smallest, what's the largest, what's some tendency in the middle. So this brings us to a question of, so what could we use as a good measure of the center for this pre-treatment weight data? And there's actually two measurements we'll talk about. The first is the mean, or what we colloquially call the average number. So this is calculated just using this formula shown here. Add all the numbers together, divide by the total number of numbers, and you've got the mean. Another measurement of the center is the median. So the median is the middle number. So I've illustrated that with just a short sequence here between 50 and 90. So if I put all these numbers in order, the middle number out of these is the number 71. And we can do this really easily with R. So we don't have to sit there and crunch numbers. And so here's the functions for calculating the mean and the median. Okay, so we'll go back over to our console and to our script. So let's just calculate the mean. Okay, and R says the mean is 82.40833. And there's also a function to calculate the median. 82.3. Okay. And I'm going to go back through in my script file here, and I'm going to add in another comment just so I can keep track of what I'm doing. Calculate a measure of the center for the anorexia data. Okay. So I have a question here. Are the mean and median similar? 82.4 and 82.3? Those seem pretty similar if you're talking about weights, right? Okay. So here's another question for you with another data set. Do you think that the mean and the median are going to be similar for these data here? So this is just showing a histogram of the population density of counties in the Midwest. So it could go anywhere from 1 or 0 to over 80,000. Okay, and then on the y-axis is the frequency. So the number of counties that have a given population density. So there are some points down here. So there are some counties that have densities of upwards of 60,000. Okay, so what do you think? Similar? Here's what we've got. So no, they're different. So The mean in this case is further to the right, and the median is further to the left. Okay, so I'm going to jump back in here to interrupt myself for a second because I want to make an important point about what I was saying about the mean and median being different for these data. So if I'm trying to describe the data that are pictured here, and I use the mean as the center, so I'm reporting a higher number, you might draw a really different conclusion about what these data look like compared to if I tried to summarize these using the median as representative of the center of these data. So if your data look like this, it's going to start to matter more what measure of the center you wind up reporting. And I'll talk more about that in upcoming videos. Okay, so that's it for talking about the center and the spread. So in the next video, we will talk about how to describe the shape of data distributions.